Hello students, welcome back to my channel. I am Honey. In this video, we are going to discuss exercise 1.3 of chapter 1 number systems. I have already made a video on exercise 1.1. You may check the video. I'll provide its link in the description box and also in the I button. Now let's get started. Question number 1 says, write the following in decimal form and say what kind of decimal expression each has. Now, a decimal expression could be of three types, right? So, number one, it could be terminating decimal expression. So, by the name itself, it is very clear that while you are dividing, a point would come where the remainder will turn to be zero, and you need to stop or end the division process. And whatever value you get of the question, okay, will be your decimal expression of type terminating. Number two, type 2 is non terminating. Now, this non terminating decimal expression could be non terminating and repeating, right? So, non terminating and repeating. Again, by the name, it is very clear that while you are doing the division process, you will get a point where you will find that the question will actually have a pattern of repetition, okay, and the remainder will never be equal to 0. It means you are just dividing, you are getting the question, and the question will have a pattern. For example, let us say that on dividing some number we are getting the question as 2.121212, and this is not ending, it will keep on going, right? And the third category of decimal expression could be, it can be non terminating. At the same point, it can be non repeating also, right? Non repeating. So, for example, you are in the division process, you are dividing two numbers. Again, the remainder will not be equal to 0 at any point. And secondly, the value of the question will not have a repetition pattern. Okay, it will not have any pattern in it, right? So it will have all the random numbers in it. For example, let us say that on dividing two numbers, we are getting the question as 3.1684508 and so on. So if you see that there is no pattern here, right? In this case, 1, 2 and 1, 2 was repeating itself, right? Whereas in this case, there is no pattern as such we have seen. So this comes under the third category, right? Now, in this question, we have to check. First of all, we have to find the decimal forms of all of these numbers, and we have to put them in either of these categories depending on our answer. Now, let's get started. On dividing, the first one, that is 36 by 100. So, let us do the division, the actual division process. So, 36 has to be divided by 100, right? So, I'll just put a point here, okay, and add a 0. So 3 times you get here 300, minus you do and you get here 60. I'll just add a 0, and 6 times it is 600. Subtract it and you get 0. So see what happened? The remainder came 0. It means the division process has terminated, has ended, and this is our question. Now if you look at the question, okay, it comes under which form of decimal expression? It comes under terminating, right? Check the first one from here. It comes under terminating, right? So this decimal expression is terminating. Its value is how much? It is 0.36. Okay. Now let us do the second question. Now second question is what? You need to divide 1 by 11. Now let us check whether it is terminating or what type of non-terminating value do you get there. Question number 2 is 1 divided by 11. So on dividing 1 by 11, you get here, let us put a point. I'll put a 0 here. Now again, this 10 is smaller than 11, so I'll put a 0 and I'll just increase the number of 0 here. So 9 times, right? It gives me there 99 minus, and I'm getting here a 1. Okay. I'll again put a 0, but this time again it is a smaller. So I'll put a 0 here and I'll just increase the 0. If you see, the numbers here are repeating, right? Again, the same 100 I need to divide by 11. And yes, and this time also we are going to repeat the number, right? So again the 9 would come here and we get here 99. So again a 1, and it will actually keep on going in the same manner, right? Just put here 0 and a 9 and 99, and again you're getting the same remainder. So if you see here, the remainder is not equal to 0, so it can be either non-terminating and repeating, or it can be non-terminating and non-repeating. Now let us check the quotient. Now the quotient that you get here is, it is 0.090909, and it will keep on coming in the same manner. It means this term 09 is repeating itself. So I'll put a bar over it, that this 09 pattern is actually repeating itself. So what type of decimal expression it is? Yes, it is non-terminating and repeating. In some books, instead of using repeating word, the word used is recurring, which means the same. So you can write as non-terminating and recurring because it is occurring again and again. The same pattern is occurring again and again. Okay. Now let us solve the next question. So it says what? It is 4 1 by 8. We are going to convert that into an improper fraction. So on converting third question, which is 4 1 by 4, sorry, 4 1 by 8 actually, into the improper fraction, we get how much? We get here 33 by 8. Now let us try dividing 33 by 8. So 33 by 8. So it goes 4 times 32 minus, you get here a 1. I'll put here a point, 0, 1, 8, 2. Again put a 0 here. 2 times 16, you get a 4 here, put a 0, 5, and it is 8 fives are 40, and you get the remainder as 0. So here the remainder is 0. So it is what? It is a terminating decimal expression, right? So this expression is of what kind? It is terminating, because we got the remainder value as 0, and the actual answer for the question is 4.125, right? Okay. Now let us solve question number 4 and 5 in the same manner, correct? So on solving question number 4, so divide 3 by 13. So on dividing 3 by 13. So here is number 3, here we have 13. Put a point, add a 0. So it is 2 times 26 minus, here it comes 4, add a 0, 3 times 39 minus 1. Next, add a 0. Now you need to add one more 0 here because 10 was smaller than 13. Now here what comes is 0 and then 7 times. So 7 times you get 91. You get a 9 here. Again, add a 0. So 6 times you get here 678. On subtracting, you get here 12. Add a 0. 9 times you get here 117 minus, you get here how much? 3, right? Keep on moving in the same manner. So did we get any point P? No. So it will again give me how much? 2 times 26. Now if you see this 30 and the same 30, right? Again the same 30 came. It means that we are going to have, if you keep on dividing, you are actually going to repeat this entire pattern. It means after this 2, you're going to get 3, 0, 7, 6, and 9 again in the same order, right? Why? Because we are getting the remainder which we actually started our division with, right? So this type of decimal expression is actually what? First of all, the remainder is not equal to 0. It means it is non-terminating. And at the same point, if we see that the pattern is repeating here, right? The decimal values are actually getting repeated here. So what can you say that? It is non-terminating and it is repeating. So question number 4 is of category non-terminating and repeating, right? Or recurring. Let us solve question number 5 now. Question number 5 is 2 divided by 11. Give me a moment. Now let us quickly divide 11, 2 by 11. So question number 5, 2 divided by 11. So put a point, add a 0, 1, 11 minus, you get a 9 here, add a 0, 8 times 88 minus 2, add a 0, 1. Now if you see this 20 and we started actually our division with 20. So what is going to happen now? The quotient is going to have a pattern, a repetition pattern here, right? Let us do it for a few more times and see. So we get here 11, the same thing is repeating, right? So you get here a 9, you add a 0 and then again 8, it gives you 88, 2. Again you end up with 2. So it means what? This division is never going to end. There is no terminating point for it. It means here what? The remainder was will never be equal to 0. And if you observe here, we are going to have a pattern, right? So we are going to have what? When 2 is divided by 11, our answer would be how much? It is 0.1818 and it will keep on moving in the same manner. So we just write it as 0.18 bar. This bar indicates that 1818 is going to repeat itself for n number of times. Okay, coming to the last one. So question number 6. 329 is to be divided by 400. Okay, so let us see that on dividing 329 by 400, what do we get? So 329 by 400. So again, this number is smaller. So we are going to put a point, add a 0 here. 8 times you get here 3200 minus you get here 90. Add a 0, add a 0 here, right? And on dividing 2 times you get here 800. Now it is 100. Add a 0, it is again 2 times 800 minus you get here 200. Add a 0, 5 times it is 2000 and you are going to get the remainder as 0. Now since the remainder is equal to 0, it comes under the first category. It means it is a terminating decimal expression whose value is how much? That 329 when divided by 400 gives us a decimal expression as 0.8225. That's it, right? Now let us solve the next question. Now question number 2 says, you know that 1 by 7 is equal to that one value, okay? So let us quickly write whatever is given. So we'll just write that it is given that 1.7 is equal to 1.142857 bar. Now this bar again indicates that this whole pattern will repeat. It means it will be like 0.142857 And again, you will get the same pattern 1, 4, 2, 8, 5, 7, right? Okay. So we have written what is given to us, and the question says, can you predict what the decimal expansions for these all values is going to be without actually doing the division? So the catch is here that we have to get the values of 2 by 7, 3 by 7, 4 by 7, so on till 6 by 7 without actually doing the division, which is quite easy, right? So how we can do this is, see, this thing is given to us. So talking about the first value to calculate 2 by 7, now can I just rewrite 2 by 7 as 2 into 1 by 7? Yes. So what is 2? 2 will be as it is. And what is the value for 1 by 7? It is 0.14285 bar. Now just multiply 2 with this entire number. So on multiplying 2 with that entire number, you would get something like 0.285714, right? So 2 upon 7 is equal to this whole value. So we did not do actual division. We just multiplied the value of 1 by 7 with 2. Now on following the same with 3 by 7. So I'll just write 3 by 7 as 3 into 1 by 7, which is actually 3 into, and again, yes, don't forget to put a bar over it, right? Because these values are going to have a pattern and they are going to repeat themselves. Okay, now multiply this whole number with 3. So you will get your answer something like on multiplication as 0.48571 and just put a bar over it. Okay. Next is fourth. So 4 into 1 by 7. So you write number 4 and in place of 1 by 7, we are going to write its value. So again a bar over it. So on multiplying this whole number, how much do we get? We will get here 0.51. Okay. It will be 0.571428 and a bar over it. Likewise, for 5 by 7, the value would be, it would be 0.714285, and lastly 7 6 by 7, multiplying the whole number by 6. Don't forget to put a bar over it, and it is 0.85714. So that's a 7. Yes. So this is the whole value. So we did not do actual division, but just by using what is given to us, we have just multiplied it with different numbers like 2, 3, 4, 5, and 6. And we have got their values. Quite easy. Now coming to the next question. Question number 3. It says express the following in form of P by Q, where P and Q are integers and Q is not equal to 0. So it is asking actually us to convert these decimal values into rational numbers, right? So there is just a small change. Actually, these are non-terminating values, right? So they have a bar over it. Okay. Now coming to the first question. Now all these non-terminating values, we need to convert it into a rational number. So for doing this, we follow a method like what we do is we say that let a variable x is equal to 0.6 bar. Now what does this 0.6 bar means? It means we have 0.6, 6 and 6 continuously, right? Okay. Now we are going to multiply both LHS and RHS. okay, by 10. Okay, so what are we going to do is we are going to multiply x with 10. We are going to multiply x with 10 and 0.6 bar also with 10. So on multiplying you get 10x, and from here see it is how much? It is 0.666 dash dash is multiplied with 10. So what will actually happen here is the point would shift and you get 6.66 and so on. So we are going to write it as 6.6 and a bar over it, right? Because it is not terminating, right? So it is 6.6 bar. Got it? Now mark this as equation number 1 and this as equation number 2. Now let us subtract equation number 1 from equation number 2 and let us see what happens. So on subtracting equation number 1 from equation number 2 we get 10x minus x. So LHS gets subtracted with the value in LHS equal to 6.6 bar will get subtracted by 0.6 bar, right? So we get here 9x, and on subtracting this value, so it is how much? It is 0.666 continuously moving, and it is 0. Again 666 and so on. When you subtract these two, the value which is after point, when see they are same, right? 6 and 6, on subtracting you are anyhow going to get 0, and that also 0 for n number of times. The point comes here and you get a 0. So can I write this number as just number 6? Yes. So we get here the subtracted value as just number 6. And here x is equal to, we are sending this 9 to RHS, we are transposing it. So on transposing, here it is multiplication. It actually turns, when it moves to other side, it will change its sign. So it is 6 by 9, or I can actually rewrite as 2 by 3 on dividing by 2. Now, if you see what was the value of x, x was this, right? And ultimately we got the value of x as this. So thus, x from here is how much? 0.6 bar, and we have converted it into a rational number which is in form of p by q, which is here 2 by 3. Number 2, it says 0.47 bar. Now this question is little different from the first one. For solving this question, let us have an idea that 0.1 bar is equal to actually 1 by 9. 0.2 bar is equal to 2 by 9. 0.3 bar is equal to 3 by 9. In the same way, 0.7 bar is equal to 7 by 9. And in the same order, 0.8 bar is 8 by 9. Right? Now let us start solving. So we are going to say what? Let x is equal to 0.47 bar, and we are going to mark it as equation number 1. Now let us multiply this equation number 1 by 10. So on multiplying equation number 1 by 10, we get that x will get multiplied with 10 and 0.47 bar will get multiplied with 10. So here we get 10x, and in the next step we are going to get 4.7 bar. Now moving ahead, let us keep this 10x as it is and try writing its expanded form. So 4.7 bar we can write as 4 plus 0.7 bar, just the expanded form. 10x is equal to 4 plus. Now what is the value of 0.7 bar? So it is 7 by 9. So we are just going to replace that with this. And in the bracket, you can just keep an idea that since 0.7 bar is equal to 7 by 9, right? And let us solve now this. So 10x is equal to, take the LCM, take the 9 here. This becomes 36 plus 7. Keep on solving. So it is 10x is equal to, you get here 43 by 9. I am writing half of the solution here. So it is 10x equal to 43 by 9. That was our last step. Now let us find the value of x. So how much is value of x? It is 43 by 9 into 10. This 10 would come here and get multiplied with 9. So while value of x is 43.90. Now just check what are the two values of x that we have. So here in the initial steps we said that x is this number and we are getting its rational number form as this. So in the next step, you can actually write that thus 0.47 bar is actually equal to 43 by 90, which is in the form of P by Q. It is a rational number now. So we have converted a non-terminating, non-repeating number into a rational number. Number 3. As I said, it is same as question number 1. So it is 0.001 bar. The meaning of this question is that the number 001 is actually repeating itself. So 0.001 and the next digits would be 0.01, 001 and so on. Correct? And we'll keep on moving. Now let us again assume that x is 0.001. Now, my idea here for solving is that I want to bring this one to whole number part. It means that this point must shift here, right? This point has to shift here so that I can bring this one to this place, to the whole number part. To do that, I have to shift this point to how many places? 1, 2, and 3 towards the right hand side. So for doing that, what we need to do is we need to multiply it with 1, 2, and 3. So a number with 3 zeros, and obviously it will be having a 1 in it, 1 with it. So we are going to multiply the number with 1000 here. What we will do is we are going to mark this whole thing as our expression number 1, sorry, equation number 1, and we are going to multiply equation number 1 by 1000. So just see how many zeros are there. We have 3 zeros and we are going to shift this point by 3 zeros only, by 3 decimal places only, right? Okay. So let us multiply. So it is 0.001 and don't forget to put a bar, right? There was a bar over it into 1000. Okay. Now you get here 1000x and here you get how much on multiplying? You're going to get here 1.001 bar because this term is actually repeating. So it is 0.001001. Let us stop here for now and multiply this by 1000. So when you multiply this whole term by 1000, how much do you get? You get here 1.001, right? Okay. Now this is our equation number 2. Likewise, we have done for the same thing for question number 1. We need to do what? We need to do subtraction. So subtract equation number 1 from equation number. And what do we get on doing that? So 1000x minus just x and 1.001 bar minus 0.001 bar. So here you get 9,000, sorry, 999 999x, and here you get, since this whole will become 0, so you will get just a 1. So what do we get the value of x as? X is 1 by 999. So thus, what was x? So thus value of x, that is 0.001 bar, is actually equal to what? Okay, it is actually equal to 1 by 999, which is again in the rational number form. So this is how you solve question number 3. Now let us move to the next question. Now question number 4 says we need to express 0.9999. It means it is actually zero point 0.9 bar. Okay, in the form p by q. So it is to be expressed in a form of rational number. So we have just learned in the previous question that how do we do that to convert a non-terminating number, okay, into a rational number. And let us first solve it and see, are we really surprised by our answer, right? Okay, so in this question we are going to say what? Let the value of x is equal to zero point 0.9 bar. Mark it as equation number 1 and repeat the same process that we did for question number 2. So multiply equation number 1 by 10, right? So on multiplying by 10, we get here 10x, and that is equal to 9.9 bar. So by now, I guess you are very clear with how we are actually solving equation number 2, okay, or how we are getting equation number 2. Next step is to do subtraction. So let us quickly subtract. So we are going to do what? We are going to subtract equation number 1 from equation number 2. So what will happen on subtraction? So you get here 10x minus x, and it is 9.9 bar minus 0.9 bar. So this is 9x. This is just number 9. X value is equal to 9 by 9. And how much is 9 by 9? It is number 1. So thus 0.9 bar, which is actually 0.9999 and so on, is actually very, very close to number 1. So are you surprised by your answer? Yes, definitely, that this value is actually equal to 1. So in the sense not equal to, but yes, it is very, very, very close to number 1, right? So you can just write, because it is asking you in the next part, discuss with your teacher and classmate that why the answer makes sense. So you can give the reason here that the value, the number 0.9999 is very close to number 1, right? So that's how you solve this one question, right? So you can just give here as, right? Okay, coming to the next question, that is question number 5. So this question is going to be, a longer question because we have to do division here and we have to actually just keep on dividing this one in this one question. So question number 1 says what can the maximum number of digits be in the repeating block of the digit in the decimal expansion of 1 by 17, and you need to actually perform here division. So let us see, we are actually going to divide it. So 1 will get divided by 17. So let us see how much do we get our answer as. So it is 0, just put a 0, another 0, right? And then it is 5 times 85 minus 15, add a 0. So it is 8 times 136. So on subtracting, you get here 14, add a 0. So it is now 140. Again, it is 8 times 136. Okay, and you get this time here 4, add a 0, 234 minus 6. So you get here 3 times 0, 51, 9. Just keep on checking if the remainder is actually repeating at any point, right? So till now, it has not repeated. So 0, 5 times 85. So 5 remainder. Did we get 5 remainder at any point? No. Again, put a 0. So it is 2 times 34 minus, so 50 and 34. Okay, so you get here 16. I'll write it here. So what do you have? You have 16 here, right? The division is actually continuing and you have 16 here now. So 16, we are going to add a 0 and we are actually dividing it by 17, right? So it is 9 times. So how much do we get? 9 times it is 153 minus 7. Again a 0, put a 4, get here 68, get a 2, 0, 1 time 17 minus 3. Okay, put a 0, 1 time 17, you get here 13. Again a 0, 7 times 119 minus, you get here 11. A 0. Now 6 times it is 102 minus, you get here 8. Put a 0. 4 times you get here 68. Subtract it and you get here 12. Again, this 12 actually moves here. So it is 120. We are dividing it by 17. So now it is 120. So 120 is again 7 times. You get here 119 minus, and you get here 1. Remainder was actually equal to the quotient, the dividend. So dividend is 1 and your remainder is also 1. It means whatever number is going to come up next after this 7 will actually be the entire repetition of this division, right? So from here till here, the next values are going to appear in the same order and all the numbers are going to be same. Okay, so what was our question? Our question was what? What can the maximum number of digits be in the repeating block of the digits? So just count how many maximum digits do we have in our question. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So for the first part, your answer is how much? It is 16. That we can have maximum number of 16 digits in the repeating block of the digits in the decimal expansion of 1 by 17. Question number 7 says you need to write three numbers whose decimal expansions are non terminating and non recurring. So that is quite easy to do because you can take any number, not just what I'm writing. So the two conditions are what? The either it should not be terminating and it should not be recurring. So it should neither end and the numbers in that should not repeat also. So you can write any example. So I'm taking the first example as you can write 13.146584231 and so on. So what is happening here that this decimal expansion is neither terminating, see it is endless, and the second point is what? Non-recurring. It means the digits here after the decimal, after the point are not even repeating themselves, right? So I can just write a 7 here, correct? So that is our first example. You can take second example as 1.0101000100001 and so on. Correct? The third one could be 0.853894468. You can write actually any number, but just keeping in mind that these two conditions are met. That's it. Now coming to the next question, that is question number 8. Now, this question is a bit different, right? So you must have solved the questions which says you need to find rational numbers in between, right? Those any two given rational numbers. But here we need to find out three irrational numbers in between these two given rational numbers. So in that case, what you can do here is that you can actually convert the rational numbers into their decimal expansion. So what I can do is I can write 5 by 7 as, so on dividing, what value are we going to get is, we are going to get here is 0.714285, and it will actually repeat itself, right? And secondly, the value of 9 by 11 could be written as 0.8181 and so on, which is actually what? It is 0.81 bar. Now we have to take any three rational numbers in between. So we'll take the three irrational numbers, sorry. So the three irrational numbers here are in between. Now I'll take these numbers. So in between 0.714285 bar and 0.81 bar R. So number one could be 0 point, let us take instead of 71, right? Sorry, 71, let us take 72. So 72, and let us write any number after that. Okay, so we can write any number after it, right? So actually this number, what I am writing here, will fall in between these two numbers. Okay, so this is one of the numbers, and you can just put three dots representing that it is endless, right? And the definition of a rational number actually is what? That the number which is a rational number must be non-terminating, and the second is non-recurring. So it is happening here, right? It is non-terminating, and even the digits here are not repeating themselves. So it is an irrational number. Coming to the second one, let us take one more number. So it can be 0 point. Now, after the 7, 2, let us take some other number like 7, 8. So I can write 7, 8 and just continue writing with any number, right? So you can write any number after this. See that you are not repeating the digits, and just put this 3, 4 dots representing that it is endless or non-terminating. The third could be 0 point. Now see, 81 is the limit, right? 81 is our limit, so we'll not cross it. So let us keep it to 801465 and so on. So whatever numbers I have written actually fall between these two numbers. That's it. So that was again a quite easy question. Now let us do the last question from the exercise, which is to classify the following numbers as rational or irrational numbers. So let me just repeat myself. If a number is a rational number, okay, you need to represent that number in form of p by q, where both p and q are what? Integers, and this q is not equal to 0. So that is the definition for rational number. Coming to irrational number, I am representing it as IR for now. So irrational numbers are the numbers which are, first of all, they cannot be represented in this form. You cannot write them in this form, p by q form. And there are conditions added to it, that they must be non-terminating. It means the division is endless, so it is non-terminating. And the second condition is what? It is non-recurring, right? So the digits must not repeat themselves on division. Okay, now let us start with the first question. So the first question is root 2, 3, that is 23. So when you calculate the value of root 23 by long division method, right? So the value that you might get is 4.7958 315, and it will keep on going because you will never get the remainder value equal to 0, right? And if you check here, it is non-terminating, and if you check here that the digits are even not repeating themselves, right? So here it means what? It is non-recurring too, correct? So we have classified the first uh, number, that is root 23, to be an irrational number. So it is an irrational number. Coming to the second one, it is what it says, it is root 225. So we all know, right? It is 15, correct? So root of 225 is 15. Now 15 is what? It is a rational number. So it is rational. Okay. Now coming to the third one, if you look carefully at the third one, it is 0.3796 and it is stopped there, right? We don't have three dots, we don't have a bar over it. It means what? It means that it is a terminating decimal value. So again, if it is terminating, it means what? It is a rational number, right? So rational numbers actually terminate themselves, right? On dividing, you will get 0 as the remainder. So that is why we call them terminating, right? Question number 4, if you check, there is repetition, right? So if there is a repetition, so you can see here 478 is repeating itself. If you find such condition, it is what? It is a rational number. Okay. And coming to the fifth one, that is 1.1010010001 00001 and so on. So there is no pattern observed here, and the division is also endless. So it means what? It is an irrational number, correct? So this is how you are going to solve question number 9. Be posting videos on the next exercise. Keep watching. Do consider subscribing to my channel. Also hit the like button. See you in the next video. Thank you.